So about 2 weeks ago, I rented some time on a couple of telescopes, the first of which is a 127mm refractor telescope that has a nice wide field of view. The other of which is a larger half-meter sized reflecting telescope that I use for follow-up observations. So I was able to collect some new data, and this is always exciting because there's almost always something new to encounter, something new to discover. And this was certainly the case on June 4, when I happened upon a Mars-crossing asteroid. So this may well be a new discovery. The truth is I won't know for sure until the Minor Planet Center comes back with a designation for this object. In the meantime, I ran those observations through the MP Checker tool, and it came back with nothing. In other words, it was not able to associate those observations with any known asteroid. So again, it may well be a new discovery, and if so, that would be pretty cool because most of the time I encounter main belt asteroids, so a Mars crosser would certainly be a step up from that. Now, as you can see in these images, these were taken with that larger instrument, the 500mm reflecting telescope, and so they were used for the purpose of generating follow-up observations of the Mars crosser. Now, what I'm actually showing here in the crosshairs is asteroid Kalliope. So this is a numbered asteroid, so it was discovered quite some time ago. But the reason I'm showing it is because if you look in this animation here, you can see not just Kalliope, but also a fainter asteroid as well. And this fainter asteroid is that of the Mars crosser. So I always think it's kind of cool when you can get a set of images where you can see two or more asteroids coming close together like this. Obviously, their orbits are such that there's no real chance of them colliding, but nevertheless, I think it makes for kind of a cool animation. So the Mars crosser is moving at about 1.3 arc seconds per minute, whereas Kalliope there is moving at about half an arc second per minute. Okay, so these are the images that were used for the initial detection of the Mars crosser. As you can see, these were taken with that smaller instrument, the 127mm refractor telescope. And again, the reason I like to use it is because it has a very wide field of view, 3 by 3 degrees, in other words, a 9 square degree field of view, which makes it very efficient at capturing a large number of asteroids all in a single pass. So for example, these are all the results that were returned from the synthetic tracking process. These are all detections. And so for example, track number 33 here is the detection of the Mars crosser. So as I zoom in here, you can see on the individual frames, it is nowhere near as readily apparent in the crosshairs as it was with that larger instrument. However, I can generate, of course, a stack of these exposures according to its motion, and then it becomes much more obvious that it is in fact a true detection. Now, stacking is of course not a new concept. It has been around for a long time now, but what is new is the ability to generate thousands of different trial stacks, each having its own motion vector. So when you're trying to detect a faint object like this, and you do not know its motion in advance, that is where synthetic tracking becomes incredibly helpful. For example, I did not know that this object was moving at 1.3 arc seconds per minute at this positioning of 336 degrees. So synthetic tracking is very helpful there. It is basically able to improve the limiting magnitude of your instrument for detecting new objects. As another example, this is a detection of a known asteroid. This is 2001 KN21, and this one has not only a very low signal-to-noise ratio, as you can see, but it also passes in front of several stars. So that's another advantage to synthetic tracking, is that it can work very well even in these crowded star fields. Okay, so by now I have 15 observations on the Mars crossing asteroid. This spans a duration of June 4 to June 11. So this is sufficient to generate a reasonably accurate orbit of the object. As you can see, I'm using Asteroid Orbit View. This is provided by David Rankin. And this is actually the best orbit viewer I've come across. It has a very nice interface, and I really like the visualization that it provides. So anyways, you can see this is a Mars crosser because it crosses the orbit of Mars. And so as I zoom in, you can see here is Earth, and then here is the asteroid. And it is certainly visible from the southern hemisphere, So I will probably continue to generate follow-up observations maybe sometime next week. But anyway, that's about all I have for this video. So thanks for watching, and see you next time.